Right, so in this video I'm going to have a look at solving some trigonometric equations, and I'm going to do a number of examples. But first let's just have a look at this triangle here. Let's take this triangle here. It's an equilateral triangle, and we'll take each side being 2 units long, and we'll split it down the middle here. So this side is 1 and this side here will be one of these two right angle triangles here. Now our angles here will be, because this was an equilateral triangle, this is 60 degrees. This is going to be 60 degrees here, and this was 60 degrees here, so this angle here will be half that. So this angle here will be 30 degrees. Now if you take this triangle here separately, this is our right angle here, this is 1, this is 2. If you use Pythagoras' theorem here, let's call this x. This will be x squared plus 1 squared is equal to 2 squared, or x squared will be equal to 2 squared, which is 4, minus 1, which is 3. X here will just give us root 3. So x here will be root 3, so this side here will be root 3. So we can use this triangle here to work out some of our trigonometric ratios for two of our standard angles, or common angles that come up in these sort of questions. So we have 30 degrees and 60 degrees here. So we can see that, for example, the sine of 60 degrees here will be 1 over 2, opposite over hypotenuse. The cos of 30 degrees will be root 3 over 2. The sine of 60 degrees will be root 3 over 2. The cos of 60 degrees will be 1 over 2. The tan of 60 degrees, root 3 over 1, and so on and so on. So we can use this, this part of our triangle here to just work out sine, cos, and tan of 60 and 30 degrees. Okay, so those angles come up very often in these type of questions. So let's anyway have a look at some examples of trigonometric equations that we can solve. So the first one I'm going to do is take the sine of theta, and that's going to be equal to root 3 over 2. And I'm going to find what the angle could be that has a sine of root 3 over 2 between, we're going to take theta being between 0 degrees here, and 360 degrees. So first thing we can do is see what reference angle would have a sine of root 3 over 2. And if we look back here, if we take root 3 here over 2, we can see that that's actually the cosine or the cos of 30 degrees here. It's going to be the cos of 30 degrees here. And it's also, let's see, root 3 over 2. It's also the sine of 60 degrees. Now we're dealing with sine here. So the sine of what will give us root 3 over 2? The sine of 60 degrees is actually root 3 over 2. So that's very handy. So we now know that our reference angle is 60 degrees. So in other words, if we draw a little xy axis here, we can see that if we have 60 degrees here, we know that if theta is 60 degrees, the sine of 60 degrees is root 3 over 2. But we are talking about angles between 0 and 360 degrees. So all the way around here, we want to see are there any other angles that have a sine of root 3 over 2? Well, we know that sine, this is positive here, root 3 over 2 is positive, and we know that sine is also positive in the second quadrant here. So if our reference angle here is 60 degrees, then this particular angle here, from here all the way around to here, is another angle that has a sine of plus root 3 over 2. And that's just simply 180 degrees minus 60 degrees here. 180 degrees minus 60 is just, so we have 180 degrees minus 60 degrees, that will give us 120 degrees. So we can see here then that theta can be, there are no other angles between 0 and 360 degrees that has a sine of, that have a sine of plus root 3 over 2. If our reference angle was down here, it would be negative sine, and here also sine is negative. So theta then has to be 60 degrees, or it can also be 120 degrees. And that's it for our first example. Okay, so let's look at another one. Let's take example number 2 here, and we'll take, let's say, 4 cos squared theta minus 1 equal to 0. And again, we'll take theta as being between 0 and 360 degrees. Okay, well, let's just simplify this a little bit. Let's get rid of this minus 1, this squared, and this 4 here. So let's add 1 to both sides, so that would give us 4 cos squared theta is equal to 1. Let's divide by 4, so we will get cos squared theta is equal to 1 over 4. And then let's square root both sides. So remember, cos squared theta, by the way, cos squared theta is just cos theta all squared. It's just the way we would write cos theta all squared. So get the square root of both sides. On the left hand side we just end up with cos theta. On the right hand side, because we're square rooting it, it's actually going to be plus or minus 1 over 2. Okay, so let's work out. If we go back to our original triangle again, we want cos to be, or cosine to be 1 over 2. So here's 1, here's 2. So 1 over 2 will be the cosine of 60 degrees. It's the cosine of 60 degrees here. So let's just work that out for all angles between 0 and 360. So again, if we just draw a little xy axis here, let's take theta is going to be 60 degrees. So if we just draw 60 degrees in here, so we know it's going to be 60 degrees anyway. So the cos of 60 degrees will give us plus a half. Now we can have cos as plus or minus a half. So really we're looking at all 4 quadrants here. So we're looking at our reference angle here being 60 degrees. We're looking at our reference angle here being 60 degrees. And we're looking at our reference angle here being 60 degrees. So what are all these angles from 0? Well, we can see that theta initially can be 60 degrees. Theta can be the angle from here up to here. So that's 180 degrees minus the 60. So that's 120 degrees. Whoops. I'll just put that in white. 120 degrees. Theta can be from here, from 0 all the way around to here. Now that's going to be 180 degrees plus 60 degrees, which is 240 degrees. And finally we can see that theta can be from here, 0, all the way around here to here. That's 360 degrees minus this 60 here. That's just going to give us 300 degrees. And if we go any further, we're back here again, but this would be all the way around plus another 60. That's greater than 360. We don't want to go that far. We're only looking for angles between 0 and 360 degrees. So these are our angles here. Okay, so let's move on. Let's do another one. Okay, so this is number 3 here. We're going to take, let's say 3 sec A is equal to 5. Okay, so now let's just talk about sec and cot. Sec is just another name for sec of theta, let's say, is just simply 1 over the cos of theta. It's just the inverse of cos. Tan, another way of writing tan is just sine theta over cos theta. And cot is just 1 over tan. the inverse of tan, which is just the reverse of this, which is cos theta over sine theta, the inverse of this, I should say. So these three here you should remember as well. Okay, so we have sec here, so we're talking about 1 over cos. So let's just work with that. Well, we want to get rid of this 3, and we want sec on its own, if you like. So that's just sec of A is just simply 5 over 3. Now sec, we can see here, is 1 over cos. So 1 over cos of A is another way of writing sec of A. And that's going to be 5 over 3. Now we want cos of A here, that's just going to be 3 over 5. So the inverse of this side is the inverse of this side. So now we've simply got the cos of A is 3 over 5. 3 over 5 is just 0.6. So to find what A is then, we get the cos inverse of 0.6, and that will give us our angle A. And when we work that out, we get an angle of 53.1 degrees. So you can do that on your calculator. Okay, now we want cos to be positive. Cos of A is 3 over 5. Cos of A is 0.6, plus 0.6. So if we draw our xy axis again, we can see here that cos is always positive here in the first quadrant. So if our angle here, if our reference angle here is 53.1 degrees, that's one angle. Now we also know that cos is positive in the fourth quadrant. So we can draw another reference angle down here. So this will be 53.1 degrees. So what is that from 0? In other words, what's this angle here from here all the way around to here? Well, that's just simply going to be 360 degrees minus 53.1 degrees, and that will give me 306.9 degrees. So we were doing this initially, by the way, I should have set up here, theta was going to be between 0 and 360 degrees. So this is as far as we can go. So our answer then really is theta is 53.1 degrees and or 306.9 degrees. 306.9 degrees. So there are two answers. Okay, let's do one more and then we'll finish up. Let's see. Okay, we don't have much more room left here, so we'll squeeze it in here. Let's take sine. Let's take sine of 3 theta equal to sine of 3 theta here is equal to minus 1. Let me just do that properly. Sine of 3 theta is equal to minus 1. Now, theta has to be between 0 and 360 again, okay? So theta is bigger than 0 and less than 360 degrees. Now, in this case, we're dealing with 3 theta here. So if theta is between 0 and 360 degrees, that means our angle here, 3 theta, is going to be between 0 and 3 times 360, which is 1080 degrees. So we want sine of 3 theta here, and our 3 theta can be between 0 and 1080 degrees. So let's do that. Now, the sine of what will give me minus 1? Well, if you take your xy axis here, we know from our unit circle that 270 degrees will give us a sine of minus 1. So from here all the way around to here, 270 degrees, that is 270 degrees, that has a sine of minus 1. So that's going to be our angle anyway, okay? So let's just write that down. So 3 theta then, we know is going to be 270 degrees anyway. And that is between 0 and 1080 degrees, so that's fine. What's our next angle? Well, if we go around 270 degrees and then go around again another 360 degrees. So in other words, we're going to go from here all the way around to here again. That angle from 0 around all the way around to here will also have a sine of -1. So in other words, what we do is we take 270 degrees, add 360 degrees, add one full circle, and that will give us 630 degrees. We're still within our range here. Okay, so let's see if we can go again. So what we're going to do now is go from here around to here and then go all the way around again, another 360 degrees. So we're going to add 360 degrees to 630 degrees, and that will give me 990 degrees. Okay, now if I add 360, if we go around again, I'll end up with an angle that's greater than 1080 degrees, and we don't want to go any bigger than that. We don't want to go any bigger than 1080 degrees. So this is these three angles here have a sine of -1. So these are our three thetas. But remember, we want to solve for theta. We want to find out what theta is, not 3 theta. We want to solve for theta. So that would mean we need to divide everything by 3. So divide this by 3, that will give us our theta. That's perfect. Divide this here by 3 and we'll get 90 degrees. Divide this by 3, we'll get 210 degrees. And divide 990 degrees by 3 and we'll get 330 degrees. So these are our thetas, and that's it really.